Hey guys, Mr. Backberg here. In this video, we're going to look at the determinant of a square matrix. Now, as we're looking at determinants, we're going to start by talking about a 2 by 2 matrix. So let's say we had a matrix A with order 2 by 2, and I'm just going to give it some general entries A, B, C, D. So in order to find the determinant of this 2 by 2 square matrix, what we're going to do is take our A value in the top left times that D value in the bottom right, minus that B value in the top right times the C value on the bottom left. And whatever answer we get when we do that multiplication and then subtraction, that is our determinant. And determinants are actually connected to the inverse of a square matrix. And they're called the determinant because they actually determine if a square matrix has an inverse. So here's how that's going to work. If the determinant is 0, then the matrix will not have an inverse. But if the determinant is any other number, then the matrix will have an inverse. So now looking at finding the inverse of a 2 by 2 square matrix using the determinant to help us out. So let's look at that exact same A matrix where we've got general entries A, B, C, and D. The first thing we check is the determinant, and we need to make sure that AD minus BC is not 0. If it is 0, then our matrix won't have an inverse. So then what we're going to do in order to find the inverse of matrix A is we're actually going to do the reciprocal of the determinant, so 1 over whatever answer we get for the determinant. And then we're going to take our 2 by 2 matrix, but we're going to rearrange the entries a little bit. We're going to flip-flop the A and D values. So I'm going to take the D value and move it up to the top left and move the A value down to the bottom right. Then with the B and the C values, we're going to leave those where they are, but we're going to switch them to their opposite. And then what we're going to do is we're going to take whatever this 1 over the determinant is, and this is scalar multiplication. So we're going to take this value times each entry in our matrix. Now in this example, we're going to look at this matrix A where we've got entries 3, 1, 4, 2, and we're going to find its inverse. And because we're dealing with a 2 by 2, we're going to find its determinant. So as we're looking at our matrix, this 3 is like our A value, this 1 is our B, this 4 is our C, and this 2 is the D value. So we're supposed to multiply A times D. So I'm supposed to take 3 times 2 minus, and then I'm supposed to take B times C. So 1 times 4. Now 3 times 2 is 6, minus 1 times 4 is 4, so we get a determinant of 2. And because we get a non-zero number, that means that this matrix will have an inverse. So we're going to find the inverse of matrix A by doing 1 over the determinant, so 1 over 2, and then we're going to do a little rearranging with the entries in our matrix. We're supposed to flip-flop the A and the D values, so I'm going to move the 2 to the top left and the 3 to the bottom right. The B and the C values stay where they are, but we change their signs. So the 1 becomes a negative 1, and the 4 becomes a negative 4. Now this is scalar multiplication. We've got this 1/2 out in front. So what I'm going to do is multiply every single entry inside of that matrix by a 1/2. So if I take a 1/2 times 2, I'm going to get 1. If I take a 1/2 times negative 1, I get negative 1/2. If I take a 1/2 times negative 4, I get negative 2. And if I take a 1/2 times 3, I get 3/2. So this matrix right here is the inverse of our original matrix A. Now we're going to look at another example in here. So we've got a new matrix A with entries 6, 3, 4, and 2. And we're going to try to find its inverse. We're going to start by checking the determinant. So I take A times D, so 6 times 2, minus B times C, so 3 times 4. 6 times 2 is 12, minus 3 times 4 is 12, so we get 0 as an answer. Because we get 0 as the determinant, that means that this matrix does not have an inverse. And the reason why we're not going to have an inverse is because as we're doing this inverse for matrix A, the very first thing we do is 1 over the determinant times this matrix. Well, we just put 1 over 0, and we're not allowed to have 0 on the denominator of a fraction, so this is an undefined value. So there is no inverse. Now, doing the determinant and finding the inverse of a 2 by 2 matrix is hopefully pretty quick and painless. But as we start to get into larger matrices, that's going to take a lot more work. So typically then we're going to use our calculator to help us out. So let's say we had a matrix A, and this is going to be a 3 by 3 matrix. Across the top row, it's going to go -2, 1, 2. Then in the middle row, I'm going to have 1, 2, -2. And then across the bottom row, I'm going to go 0, 1, -1. And I'm going to use my calculator to help me find the determinant and then find the inverse of this matrix. So in my calculator, I go second matrix, and I'm going to edit matrix A. It's a 3 by 3 matrix, and we're going to go -2, 1, 2, 1, 2, -2, 0, 1, -1. So there we have all of our entries for our matrix. Now I'm going to quit out of here. And the first thing I want to find is the determinant. So I'm going to go second matrix, and I'm going to go over to math. And the first option in there, that DET, that's the determinant. So I'm going to pick the determinant, and then I do second matrix. And we just entered our matrix in A there. So we're doing the determinant of matrix A. I hit enter, and we get 3 as the determinant. So that means that our matrix will have an inverse. So then in order to find the inverse of this matrix, we're going to go second matrix and grab matrix A, and then I'm going to hit my X with the -1 on it. So this is the inverse of matrix A. I hit enter. Now there's a lot of decimals in here right now, and we actually can't even see some of the entries. So one thing that I like to do with these, if I see a big long string of decimals, is I like to turn them into fractions. So I'm going to hit my math button and turn this into a fraction. So then it gives me this matrix with these fractional entries. So this matrix is the inverse of our original matrix A. That's going to be it for this video. Thanks for watching.